Welcome to another episode of learning. I thank each one of you for watching my videos and encouraging me. Please like my videos and share them with your friends and colleagues. Please subscribe my channel if you have not already subscribed. Thank you. We continue the discussion of the solutions of the problems that have appeared in the CSIR National Eligibility Test held on February 28, 2025. In this video, we discuss the solution of a problem from the section Linear Algebra, which is related to linear transformations. The question is placed in part C, which is a multiple select question. There can be more than one answer and it carries 4.75 marks. The question ID is 704151 and this question is suitable for all these examinations. Right. The given question is, for a variable x, consider the real vector space V is equal to the set consisting of ax cube plus bx square plus cx plus d, where a, b, c, d are real numbers. Let D be a linear transformation from V to itself, defined as d of f is the derivative of f with respect to x. And M is a linear transformation from V to itself, defined by M of f is equal to x times d of f. Which of the following statements are true? We are given four options. Option 1, dm not equal to md. Option 2, d plus m is invertible. Option 3, dm is invertible. Option 4, rank of dm is equal to rank of md. Right. Let's now discuss the solution of the problem in detail. We have the real vector space V. It is the set of all polynomials of degree at most 3 with real coefficients, that is ax cube plus bx square plus cx plus d, where a, b, c, d are real numbers. It is a vector space over R and its dimension is 3 plus 1, that is 4, and the standard ordered basis of V is given by B is the set consisting of 1 x square x cube. Right. Now, given the linear transformation d from V to itself, defined by d of a polynomial p of x is equal to its derivative with respect to x, p prime x. And we are also given m, a linear transformation from V to V, defined by m of p of x, a polynomial, is equal to x times the d of this operator d of px, and that is x into d of px is p prime x. Agreed. Now let's take up option 1. Is dm is equal to md? That's the question. Right. Now dm of x means d of m of x. What is m of x? M of x is x times p prime x, that is x into 1. D of x is 1. Right. And md of x is m of d of x. D of x is derivative of x, that is 1. And m of 1 is x times the derivative of 1, that is 0, x dot 0, 0. So, now dm of x is 1, md of x is 0. Therefore, dm is not equal to md. Thus, dm is not equal to md. If dm is equal to md, dm of p of x is equal to md of p of x for all p of x belongs to v. But it is not so. Right. So, now option 1 is true. We move to the next slide for the second option. Second option, d plus m is invertible. Now, we will show you that it is not a one-to-one function, one-to-one operator. One-to-one operator. So, d plus m of p of x will be equal to d of p of x, that is p prime x, plus m of p of x, that is x p prime x. We have used the definitions. So, that is x plus 1 is multiplied by p prime x, that is d plus m. Right. Now, for any real number r belongs to r, any real number r belongs to r, when r not equal to 0, it is a polynomial of degree 0. Right. So, that is d plus m operating on r will be d plus m operating on r, p of x is r. So, that is x plus 1 into the derivative of r. The derivative of r is constant, that is 0. So, that is 0. So, every r belongs to r is going into 0 under d plus m. So, that means the various elements of r are all going to 0. So, it is many to 1. So, therefore, it is not 1 to 1. So, d plus m is not 1 to 1. When it is not 1 to 1, it is not invertible. Who are the invertible operators? Who are linear transformations? Which are both 1 to 1 and on. But it is not on 1 1. So, therefore, this d plus m is not invertible, and thereby option 2 is not true. Right. So, now option 3. Is dm invertible? That is the one. Now, dm operating on p of x, that is d operating on m of p of x. M of p of x is x times p prime x. Differential d of x of p prime x, differentiate. Differential of the first is 1 into p prime x. First x into differential of the p prime x is p double prime x. Right. Now, for any r belongs to r, again we do the same exercise. dm of r, so p of x is r. So, p prime x, derivative of r 0, derivative of double derivative of 0, double derivative of r is 0. So, everything is 0. So every r belongs to r is mapped to 0 under dm. So, it is again many to 1 function, therefore, it is not 1 to 1. Therefore, the option 3 is not invertible. Option 3 is not true. Agreed. We move to the next slide. Option 4. Rank of dm is equal to rank of md. Okay. We have dm of p of x. We have already seen p prime x plus x times p double prime x. dm of 1. So, p of x is 1. It is 0. Derivative is 0. Double derivative is 0. dm of x. The derivative of x is 1 plus x times the derivative of double derivative of x is 0. So, it is 1. dm of x square is p of x is x square, p prime x, that is 2x, x into p double prime x, that is 2x, so 4x. dm of x cube, 3x square plus 6x square, 9x square. So, now see, Let us calculate the range of D of M. Why are we doing? We want rank. How do we find rank? Find the range of it, take its dimension. Then you will get rank. So range of dm is equal to the span of the linear span of dm of 1, dm of x, basis vectors, dm of x square, dm of x cube. The linear span of 0, 1, 4x, 9x square. This is a linear span of 1, 4x, 9x square. Now they are linearly independent. So therefore this will be a basis for the range of D of M. Then its dimension will be number of elements present in the basis, that is 3. Now the rank of dm, by definition, the dimension of the range of dm, the dimension of range of dm is 3. Right. We move on to MD. So MD of P of x is x P double prime x. Right. So again, dm of 1. For 1 x times the second derivative of 1 is 0. dm of x is also 0. dm of x square, it is x into second derivative of x square is 2x. dm of x cube is x into second derivative of x cube, that is 6x. 6x into x, 6x square. So now we again calculate the same thing. The range of MD, R of MD means range of MD. It is the span of MD of 1, MD of x, MD of x square, MD of x cube. It is a span of 0, 0, 2x, 6x square. That is, this is a linear span of 2x and 6x square. They are linearly independent, and therefore this will be a basis, and the number of elements present in it is 2. Therefore, the rank of MD is equal to the dimension of the range of MD, that's equal to 2. So, thus the rank of DM is 3, the rank of MD is 2. They are not equal. But in option 4 it is given they are equal. Therefore, option 4 is not true. Summarizing all the options, only one option is true, that is option 1. So the answer to this question is option 1. That is the detailed discussion of the solution of this problem. In this problem, the properties of linear transformations, in other words, is tested. Is the student familiar with all the properties of linear transformations? That is tested. Agreed. I am sure that you have understood the solution of this problem. Thank you for watching this video now. I thank each one of you for watching my videos and encouraging me. Please like my videos and share them with your friends and colleagues. Please subscribe my channel if you have not already subscribed. Yes, certainly we will meet you all again in another episode of learning. Enjoy learning mathematics. I wish you all the best. Thank you.